We are solving now a paper 2, section B, probability question. I would say this is well, short, long question. It's just only 11 marks. And I think you should stop now the video and read exactly what you're asking this question. So let's look together what's going on. So there is a bag where we have balls of different colors. It says over here that there is one that is green, and then there are two that are red. There are two people playing this game, Eva and Barry, and the way it works is that they randomly select a marble from the bag, and then they look at the color, and then they replace it back. So that's very important. The game is with replacement, so each time there will be again one green and two red marbles. Eva wins if she gets a green marble, and Barry wins if he gets a red one. And Eva is the first one to start the game. So she'll get the hand in, take a marble, look at the color. If it's green, she won. If it's red, it's Barry's turn. For part A, we are asked to find what is the probability that Eva wins on the first turn. So Eva wins first, abbreviation for first turn. So that means that she will put the hand inside the bag and will take a ball, and that ball will turn out to be a green one. And that happens with probability 1/3 because there are 3 balls in total and only one is green. For part B, we want to find the probability that Barry wins on his first turn. So probability Barry wins first. So that means that the sequence we need to have is that first Eva takes a marble, and that one is red because otherwise she will win and the game is over. And then in the next step, Barry takes a marble, and that one turns out to be red as well because that's what makes Barry win. So for this to happen, for Eva to get a red one, that's going to have probability 2/3. And then we multiply because it's part of the same experiment. We keep going with the experiment. Now Barry takes a marble, and then that's to be red as well. So it has probability 2/3 again. So this is 4/9, the probability that Barry wins on the first turn. For part C, we want to find the probability that Eva wins in one of her first 3 turns. So probability Eva wins first or second or third. So any of those three possibilities are good. And of course they cannot happen at the same time and they are independent. So that will be the probability that Eva wins in the first plus the probability that Eva wins in the second plus the probability that Eva wins on the third turn. For the first one, we already found it, is 1/3. For the second one, what we need to happen is first, Eva doesn't win, so Eva gets a green one. So that will have probability, sorry, not a green one, a red one. So that's going to have probability 2/3. But then what we need to happen is that Barry doesn't win either. So he gets a green one. So Barry green, that has probability 1/3. And then it becomes Eva's second turn, and she does win, so that has probability 1/3. So this was for the second turn, and if you look at what we have here, this is the first turn, none of them winning. Now, if we are looking at the probability of Eva winning in the third turn, what we need is obviously that none of them wins in the first turn. That's 2/3 times 1/3. But then we don't want any of them to win in the second turn either. So we have 2/3 times 1/3. And then we want Eva to win in the third turn. So that has probability 1/3. And we need to sum what all those probabilities are. And that's actually, in fact, 103/243. Now let's look a bit carefully again. Why do we have sums over here? We have sums over here because each of the terms we have, they represent the probability of winning in one of the turns. So this one is winning in the first, this is winning on the second, and this is winning on the third. Those events are independent. They're all good for us and they are independent because, well, the bulls don't know what happened in the previous turn, so they can't change the way they behave, right? So that's why we are summing each of those three probabilities. Now, why are we multiplying inside each of those probabilities? You can imagine that this is like a tree diagram. So we have the first turn, let's say. There are two options. It could be that Ava gets a green ball and then the game's over, or Ava gets a red one and then it's Barry's turn. He could get a green ball and then the game continues, or he could get a red one and then the game is over. If he gets a green one and then there are two options again for Eva, it could be that she gets a green one, or it could be that she gets a red, and so on. So, for instance, in the tree diagram, we can see the probability of winning in the second turn as Ava doesn't win in the first turn, Barry doesn't win in the first turn, and then Ava wins in the second turn. So to find what is the probability, we are multiplying along the branches because the event is made up of the consecutive choices of red, green, green. Maybe you have seen by now what is the probability of Ava winning in the fourth term. They are not asking for that, but it will be nice to see it because then it's going to be very easy to answer part D. Well, first of all, she's not winning in the first turn, and neither is Barry, so none of them is winning in the first turn. So we have a factor of 2 or 3 times 1 over 3. And then they are not winning on the second one, so we have another factor of 2 over 3 times 1 over 3. And then they are not winning in the third one either, so 2 over 3 times 1 over 3. And then finally she wins in the fourth term. So what we have over here is actually a geometric sequence. The first term is 1 over 3, and then the common ratio is 2 over 3 times 1 over 3. And that's what we have here to the power of 4 minus 1. Note that I could write here 1 over 3 times 2 over 9 to the power of 3. But in purpose, I kept writing 2 over 3 times 1 over 3 because I think it makes more clear where that factor comes from. That Eva picks red and then Barry picks green. So now it won't be too hard to answer what is part D because we see that the probability of Eva winning in the nth turn, this as a function of n is a sequence that is geometric sequence. The first term is 1 over 3 and the common ratio is 2 over 9. That was the 2 over 3 times 1 over 3. So when they ask us the probability that Eva eventually wins, what we are trying to find is, well, the probability of winning in the first one plus the second one plus the third one plus, and we keep summing forever. So this is the infinite sum of a geometric sequence. Let's call it S infinity. And that's given by, this is the formula in the formula booklet, the first term divided 1 minus the common ratio. And in this case, this is 1 over 3 over 1 minus 2 over 9. And you can find out that this is 3 over 7. I just want to mention something that I didn't say, but was implicit. When we look at the common ratio being 2 over 9, that means that the absolute value of the common ratio is less than 1. And that's why we are able to find the infinite sum of this sequence.